Welcome to the Roniel and DaRon podcast show. I'm DaRon.
And I'm Roniel.
In this special edition, we're going to take a quick peek, as these things go, at some of the recent issues that we've seen regarding Log4j2 in particular. So, our goal is to examine the causes and the code in question that is making such a kerfluffle, and then also examine some of the other lookups and understand better how this works, how all of this winds up working from a code perspective. This is one of the most obvious cases for why we as security professionals have to be able to read code. You should be able to write code, but you definitely need to be able to read code. The reason why you should be able to write code is because it's hard to give actual remediations. It's hard to give solutions and things of that nature if you don't actually know how to write code and if you don't understand the language in great detail. It's one of the keys about security in general, be it application security or otherwise. If I'm sitting there working with a Cisco router and I don't know Cisco, then I may be able to find a vulnerability, but I will be much less likely to give actual applicable remediation steps. And I would also probably be less likely to be able to determine the full breadth and depth, so the full scope of the issue. Looking at this particular setup, this is the Interpolator. This is where all the evil black magic is going on. So the Interpolator, we'll go through and we'll run through a debugging step later. But the Interpolator is solely responsible for running these lookups by default. Now, I will say something a lot of people are ignoring is that you can have custom interpolators, you can have custom configurations, and you can have custom lookups and maps. And that's going to impact the scope. It can actually narrow it or it can widen it out depending on how you do this. Most people, however, are using a plain Jane kind of setup, and that makes this much easier to talk about. So we'll notice that what they do is they create this lookup map, and it's a key value pair. Each one of these maps, when we see, here's my key. So if I were doing something malicious, it would be $ curly bracket key, and then they're using a colon for a delineator. And then after that, you put in whatever it is, and then you do curly bracket. Now, there is an alternative version of this. There is both the key value and there is also the key value and then alternate. And the way that winds up working is if I specify a major key and then a value tied to that, which is actually another key, then if that key isn't found, it will use the backup key instead. Just to give a quick example, let's take a quick peek at Log4j. So we're going to look at the Log4j lookup first. When we look at this, we see what gets called for each one of these is going to be lookup. So lookup has two keys, and the default, of course, is returning null. Anytime it returns null, it's just going to spit back out whatever it is you gave it. So if it were curly bracket log4j colon pizza, well, pizza isn't one of these two values. So when you look in the actual logs, what you will see printed out is pizza, as well as the rest of the context string. What you wouldn't see would be a value associated with that. So when we do each one of these, this winds up in this case returning two strings. So it can either turn the absolute path or it can return the parent location's absolute path. And let's take a quick peek, see what all we see. So we're going to grab the config location. This should tell us where our configuration file actually happens to be. And we're going to adjust it. We're going to place it right in here. Now the key again is log4j, and we know that key because that key is sitting right up here, but also again we saw it in our interpolator. So looking at log4j, we're going to do our colon, and we give it configuration location. Now, we can see in the logs what is outputted by this. So if I refresh, I scroll down, and I can see my location was swapped out. The location is only swapped out during the logging process. So before logging, what my system actually saw, and we'll see this when we run through the debugging, was this ugly little text. And this, of course, is going to fail validation on our side. This is one of the unfortunate things is so often we say log, 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 log. Logs are great, logs are important, it's good to have logs. Well, if there's some kind of a problem, then we can look at the logs and see what all happened. The problem here is now we have log injection, and this is something people aren't talking about because to many people in the grand scheme of things, this is a minor issue. But the user didn't, or the attacker didn't input this string. The attacker input the key, which we then mapped over to this string. Now, remember I said there are actually two major forms of this. There's one more form where we have a default value. So let's say I put in something that doesn't exist, like pizza. So under this major form, I can actually tell it to go through and call to my proper value if whatever it is we're looking for doesn't in fact exist. And that's through that default option right here, which says if the thing on the left, which is pizza, doesn't exist, then call this one instead. Put in that data instead. The main point and purpose of all of this, as you'll see, really was for logging purposes, more for logging configuration than it was anything else. Why it managed to bleed from logging configuration into actual logged data is really thanks to the way that they do it, which is not intelligent. It was not well written. It's the problem is akin to if you abstract something to such a great degree that now all data flowing through is potentially configuration is what ultimately winds up happening. And when that occurs, that includes user data, which now means the user can, for all intents and purposes, be configuring as they go through and write. Looking at this, we see we have log4j, we have sys, we have env, which is environment, we have main, marker, Java, lower, upper. Now we see we also have, again, this is just by default, JNDI. We have the Java runtime args. We have the Java virtual machine arguments and JMX inputs. We have date, we have CTX. The CTX is our context. We have web-based lookups. We have Docker lookups, Spring, and Kubernetes lookups. The DateLookup exemplifies exactly how this was designed more to work from a configuration perspective than anything else. If we look at date, we can see here date again is our key, and all lookup does is run a format date call. Format date itself just takes in that user input and pushes it to simple date format. It's not an intelligent thing to do. It's not a good thing to do, not from the security perspective, but they then take whatever that string coming out of it is, and they format that date according to whatever the user supposedly inputs. So if I have an attack string like this, where I have my year, month, date, PT, which is just standard, HH, $SS, what I wind up seeing is my date outputted exactly as I see it here. So we have that date in this format, just like we had asked for. The upper and lower lookups only take whatever the user inputs and then spits it back out either as an upper or a lower. So if I, for example, broke this up and we had date like this with lower, this would still be the same as running date itself. That's important to recognize because a lot of what you're seeing from people are regular expressions supposedly that will help you detect these attacks, and they just don't work. The reason why they don't work is because too often their regular expression is far too specific and very much not a regular expression. So it won't catch anything that happens to be encoded, and it won't catch anything that happens to be in a format like this using lower, using upper, or using things like the default minus D, which would actually be the exact same thing. Because as we saw earlier, this says if I don't have a key value pair like this one, where it's empty and empty, which we don't, then output D for date. And that's exactly what it will do. The way this operates is it takes the innermost first and expands, expands, expands. The reason why that then becomes a problem is because you can exhaust resources pretty easily. There are a variety of denial of service attacks based solely upon this expansion. There are also several denial of service attacks based on using that default and based on using the fact that they don't properly check. This prints out system properties. EMV prints out environmental properties. So your environmental properties, of course, things like Java ops. So you're guaranteed in an environment like this that it's going to have Java ops. Mostly because we know that that's just what it's running. When we scroll down, we can see all of our Java options. Again, a lot of people probably would look at something like this, say it's fairly innocuous. What does it matter? And the answer is by itself, just in this format, other than the log injection, it doesn't necessarily matter. The attacker hasn't been provided any data, and they don't gain much from this. However, outside of this incredibly specific example where we literally are just pumping data into your log file, we can do an awful lot more. We could, for example, send it to ourselves. We could do that in a variety of different ways. Or we could go through and replace this with something more meaningful that rather than just dumping out data, actually execute something useful based on a given lookup. And that's all very specific to the given lookups. Some lookups provide more than others. Some lookups are more dangerous than others. If we look at main, all main does is spit out our arguments, any argument sent to the public static void main. So everything contained within this happen to get returned. If there are no arguments, then it gets spat out such as it is. So this isn't necessarily a big deal unless you happen to have something sensitive in your main arguments, maybe credentials. So that's more common for something running courts where they may pass in credentials or some other scheduler. It's not as common for something that's being run from the command line. It is possible if we were in something like AWS, your system variables, which we can look up, your system properties, or your environmental variables may contain credentials, especially if you're in an environment like AWS or Google Cloud or Azure. And that's where either of those two would become more important. So an attacker could leverage those to exfiltrate credentials from your system and then use that to authenticate. If you set up anything like the Java, uh, anything like the Tomcat manager credentials through environmental variables or system variables, again, someone can go through and use this to look them up and send them to themselves and then authenticate. So the sky's really the limit. And this tends to be the case with most vulnerabilities. It's not a question as to what the vulnerability does on the surface. It's a question as to what you can make it do for you. And that's based on your own ingenuity or lack thereof. The marker lookup is solely around the markers inside of the actual query. So if we were, for example, to look, it doesn't really tell you here what a given marker is, but a marker in Log4j are the curly brackets. So anytime you're looking at a string that we're logging and you have curly brackets, those are your markers, and each pair of curly brackets happens to be a marker. If we were to look at a good example of this, we would have to look for something in the DAO maybe. This would be your first marker for this particular message. And then we can have 2, 3, 4, 5 markers, however many markers you want. So those are your markers. So JavaLookup, this can give you a whole host of data. I've actually seen a lot of people using this particular one in the wild, where the first thing they do is they have your system spill the beans, so to speak, about what operating system is running, what system properties are being run, environmental data, what your hardware is, all that kind of stuff. So looking at this, we've got get hardware, get local, get operating system, virtual machine. And we can see the different names here for what the get virtual machine is actually going to call when it makes these system property calls. And then we can see the corresponding key lookups here. So it'd be Java version, Java runtime, Java VM, Java OS, Java hardware or HW, Java locale. And if it doesn't get anything, unlike some of the others which just return null, this one now is going to throw an illegal argument exception and throw a gigantic hissy fit. So after we've decided what the JNDI name happens to be, we then do our lookup. It's during that lookup process that it connects to whatever the resource is that you've specified. And then they make a map tied to that, and we can see the map through this context lookup. And that's when all the big bad evil actually occurs. This is when we wind up connecting via JNDI to whatever the malicious entity is and absorbing all the tasty badness. Next, we see the JMX input arguments, which is hit via the JVM run args lookup key. That spawns a call to here. This one maps our actual JVM input arguments to a given key, whereas with some of our previous ones, it was your system variables, environment variables, and your public static void main string args arguments. For this one, this is your actual JVM, so your Java virtual machine input arguments. So if you had specific arguments for your JVM, they would appear in here inside of this map as part of this lookup. We've already taken a peek at date. Context looks up your thread context, but it is important to note that this can be custom in and of itself. So the way they do this is via this injector factory that they create. So if we look at this injector, we see that they check to see if there's this context data injector property. If there is a context data injector property, then they're going to load that class and use that as their context data injector for the lookups. If there isn't, then they use their default. Their default itself uses the thread context map. And you'll note that we have 3 different options here. So the default option here, of course, is this default thread context map. Then if it's copy on write, we have this context map. And then for garbage-free thread context mapping, we have the other one. Looking at the default, we can see this call to get providers for the default. Get providers calls init service providers. It then sets up some arrays, and then it adds everything from there into there. So your CTX can have a wealth of data. It can be incredibly important, and it can give attackers access to the actual thread context, which would be highly disadvantageous, particularly because while this appears to be a write once kind of action, it actually isn't. And that's what one of the latest vulnerabilities that came of this was. And this goes for any of them. I can actually have a redundant lookup buried inside as the default and use that to pseudo override what the given context mapping happens to be, so that I create an infinite loop. And that actually tends to be an issue with each one of these, and it's not simply just the context map. This, of course, again, varies depending on your particular setup. So one of the important things is, from an attack perspective, it's a fairly inconsistent means of attacking someone under the current constructs. So next we have whether or not they are a web app. This particular condition only looks up what classes are loaded, and based on what classes are loaded, it determines whether or not you are in fact a web application. And if you are a web application, then you get this fancy new lookup here. For this lookup, we see starts with prefix, and we've got this attr and init param prefix. We have if root dir equals key, then it's got the real path. We have context path name, context path, servlet context name, servlet info, effective major version, effective minor version, major version, minor version. If we get past and the key is not empty, if CTX, so the context get attribute returns whatever this thing is, then it's going to return the value of that. And if context.get init parameter returns something, then it will use that instead. The nice thing about web is web in and of itself, we'll see here. So if web, let's say we're looking at attribute, it then calls context.get attribute, trying to grab that data from the context. If we're calling init parameter, then instead of doing a substring based on that prefix, we do a substring based on the init param prefix, and then we do that get init param. So an attacker can do web colon attr dot whatever. They can do web colon and then whatever that happens to be, if it happens to be something that was not up above but is in fact an attribute or an init parameter, then either one will actually walk away with the same general thing. Next, we have DockerLookup. I kind of don't understand why people aren't talking about the Docker or Kubernetes lookup much, but maybe that's just me. For the Docker lookup, the first thing it does is it tries to grab the Docker URI from system.get environment. If that is null, they grab the properties and then try grabbing the Docker UI from there. If it's still null, kicks out. It's like it never even happened. Container is null and we return. If it's not null, the container current is set to null. They then try to grab this data from this URL. So this is going to be a JSON string coming from that particular URL. And then the next thing that they do is they actually parse it. So the way they parse it is not secure and it's not proper. I don't understand why there aren't more people complaining about the fact that this action here actually opens them up to a slew of different vulnerabilities, to include insecure deserialization, based on how they are deserializing that supposed JSON. I don't know why no one's talking about the way they're grabbing the networks, etc., is wrong, and about how someone can attack this system just like they can struts, etc., using insecure deserialization from a malicious Docker instance. However, I'm sure a lot of people would probably argue if you have a malicious Docker instance and you're doing a lookup, it's already game over. But the point still remains, if I somehow manage to control JSON, which is very possible without having control of the application, which again is very possible, and I can convince your system through a Docker call to then query my Docker instance, I can convince your system to then execute whatever it is I want through insecure deserialization. Don't understand why people aren't talking about that, but whatever. So with Docker, we then have, after it's done parsing that, short container ID, container name, short image name, image ID, and image name. Looking at SpringLookup, which is the next thing we have. This is our handy little SpringLookup. We have profiles active and profiles default. We'll pay attention to those strings. So lookup itself, environment, get environment, they lowercase a string, that value that we send over. So remember, we're going to say spring colon, and then we've got a value tied to that. They're going to lowercase that. They check to see if it starts with the word profiles.active. If it does start with profiles.active, then we break into this particular switch. So this switch checks the length, and if the length for profiles for the environment get active profiles is 0, it doesn't return anything. If the get environment dot get active profiles winds up returning 1, then it just sends over that profile data. If it in fact returns something else, they run this matcher, and the matcher of course looks for a digit. Then they parse that and they check to see if the index is less than the length of active profiles. If it is, then they return that data. So let's say it's 12 and there are 12 active profiles, that's going to fail. But if it's 11, which would be proper, since of course we know it starts with 0, then it's going to return the data from a get environment, get active profiles, index 11 call. If it's default, then we do something similar. It's fairly simple. It's just based on whatever the default is for that Spring profile. The last in this list is the KubernetesLookup. So taking a look at the KubernetesLookup, we have this Spring bit It checks to see if Spring is included by, again, checking to see if this class happens to be loaded. If the class is loaded, then Spring is included. If the class is not loaded, Spring is not included. We use this reentrant lock for thready goodness. They lock. If Spring is active, they check to see whether or not Spring is active. Then they try to grab their Kubernetes information. If Kubernetes info is null, or either Spring is not active according to Kubernetes info, and it is active according to our quick check using this Spring is active. So if these two have some kind of disagreement, then they pull the Kubernetes data using Kubernetes info here. Kubernetes info is very simple. Here we have that same issue where we're doing a lookup, trying to grab that pod based on that host name. Importantly, when we do this, the pod can either have been specified when the Kubernetes lookup was created, as we see here, or it can be specified after the fact. If it's specified after the fact, then this is all based on configuration stuff, then it tries to use the environment host name, but that's only if the Kubernetes client builder actually returned it. From there, it grabs the data from the pod, from whatever client it connects to, attempting to get our metadata tied to the Kubernetes instance itself. This winds up running into a similar issue as to what we saw from Docker. It's not well done, and it in and of itself allows similar issues as to what we've already seen from the JNDI and elsewhere, but also similar issues as to what we see from struts itself. We see the account name, annotations, container ID, container name, so on and so forth. So if you were to query it with any of this data, then it would return something hypothetically back, unless, of course, there is no Kubernetes pod, in which case nothing gets returned. So that's a quick walkthrough of the code. It's more complicated than that. And if you actually look upstream from what's calling Interpolator, which we will, you'll see a little bit more involved, but that gives you this default look when we're trying to do something malicious. So next we're going to run an actual debugging instance, and we'll walk through the debugger real quickly. So we're going to send over our malicious query, knowing that this is going to cause our exception to be thrown. We've sent our malicious message. We can see the string such as it is in here, and we see that it includes, of course, exactly as we had put in. We're going to enter the logging. Enter again. Log message safely, which is an ironic name, considering. They create a new message factory for each one of these. The message factory isn't a big deal. It's the config that's actually where all the trouble occurs. And we'll get to that in a second. So here they're trying to grab that strategy. The strategy winds up coming with a configuration. And configuration is what they then later on use and via the logger config. So we enter in the log call. We go through, here's our get active logger config. This is where that config actually gets set up. And now we go into the log properties. We go here. So this is the event creation. We can ignore the event creation. It's not a big deal. But it looks real quickly just like this log. Now we're going to go into that. So whether or not the log is filtered, process the log event. Include location is yes. We do want to include the location in this particular one. We're going to allow. Call the appenders. And the appenders is where it's actually logging to the different files or whatever it is you tell it to log to. So this grabs our appenders. So now we're going to try to append the actual event. Now this is our rolling random access file file appender. The rolling random access file appender happens to just be what we have ours set up with. So they grab the manager, they check rollover. You see this is just whether or not the log should roll over. They set end of batch. I do enjoy the comments you see within a lot of the Log4j stuff. Most of these comments are absolutely ridiculous. Stuff like fix me, stuff like this is 15 bytes, don't touch it, be careful if you touch it because you'll blow it up, all this other crazy stuff. So now they try to append. So git layout, here's our pattern layout where they would do any encoding that they need to do. And this is where our evil itself actually occurs, is right here within the message pattern converter. So message pattern converter is responsible for converting a given message based on how the string supposedly smells. In this case, what it's looking for are our semicolons. We see here I love this. So this is whether or not no lookups are specified. So if it's not supposed to do lookups, then it won't walk through this. But since it wasn't told to not do lookups. So we see here it is quite literally just looking for $sign and the curly bracket. And it just marches through trying to find $sign and curly bracket. This is the most inefficient code ever written. What we see wind up going on below is this get string substitutor replace. That's what's responsible for all of the evil because it's what's responsible for later on calling our So it's found that $sign curly bracket that it was looking for, which is all that message pattern converter is looking for. And then it creates a substring based on that. So the value now of our value is such as we see here. What we ultimately really want is to see this from the breakout. We have our substitutor. Source is not false. So we see the variable prefix matcher is, of course, there. It's the $sign and curly bracket. The suffix matcher is, of course, the closing bracket. The escape character is the $sign. The value delimiter is, of course, our colon. And we see here that it allows for that minus as well. Is enable substitution in variables. That's set to true by default. Prior variables is null. There are no prior variables. Altered is false. Length. The characters, it's going to grab our characters. Buffer, positive. So long as we have something to march through, So we're going to march through this quite a bit before we finally get to where we're after. It's just going to slowly walk the string despite actually having everything it needs to go through and quickly match that prefix. So we finally got to the $sign, and it's an unescaped $sign. You'll note to escape it, you'd have a $sign. So $2 would be your escape $sign. So we see our start position is 175. Now it's going to go through. The end is unknown. Is substitution enabled? The answer, of course, is yes. Does the matcher equal? The answer, of course, is no. So they want to look for that end marker. And then within the end markers, they're actually going to want to find the last end marker possible. So when they find an end marker, they count the nesting. And the way they're doing that is they, of course, look for another $sign and curly bracket. Once the nesting count is finally equal to 0, then we're going to get down to business and actually do something fun and exciting, maybe. Right, so we finally got to the end of it. Of course, this one's very simple. So why they do all that work, I don't know. I would have just used a pattern matcher or something and done some counting. So substitution is enabled. So they're going to get this string builder. They see it's env java ops, which is exactly what we want. Now we go to substitute. And now we're in the string substitutor. So it gets this, and you'll notice we walk right back through this. Why? Because this is how they work. So it's grabbed the entire thing and it's going to run all the way through it again, just only with that string. So if the var delimiter is not null, meaning we have a colon, which we do, java ops, value delimiter. So again, we're going to keep checking if the substitution in variables is enabled, because if you didn't check it the first 10 times, by golly, you have to check it now. So you'll notice how we're going to march through this. So we just did the E. Now we're going to do the N. Now we're going to do the V. And now we're finally going to do the colon. So this is true. It will match. So now we know off to the left is the variable name. Off to the right is everything else. It's going to look for that default value. Prior variables, there are none. We finally get here. Check cyclical conditions. So this is supposed to check to see whether or not the variable name is a prior variable. The problem here is actually exactly what we were talking about earlier. If context is set and has user, I can make use of the default value to add something that doesn't go on here, because what you'll notice is that the default value does not enter the prior variables. The only thing that enters is the original value, or the original value plus the default string. So it's going to prevent you from querying the same thing twice via a cyclical call within a given call. And this particular code, of course, was broken. So now it's going to do the resolve the variable. So here's our lookup. Resolver is not equal to null. It's going to actually run the lookup. position is 3, and now we get to exactly what we were looking at before. So the last one we'll show real quickly is that JNDI lookup and how that walks through, just so you can see that through a debugger. So skipping through all the stuff we don't need to see. We see, of course, here we have the lookup. Now we're in JNDI lookup as previously promised. Here's https evil.local. It's going to move forward. We see, of course, that returns https evil.local, just as promised. That grabs our default manager. And now we perform our lookup. We can see Catalina actually making the calls. That's it for this special edition. We hope you found it interesting and hope you maybe found some new ways to play and some new things to look out for. This is a very simple vulnerability, and we showed only what we thought was interesting that most other people are ignoring and missing. There are other major issues that we're not going to discuss because they haven't been publicly released, and we would rather not be the source of further exploits. An important thing to note is that a lot of this could have been prevented by simply not assuming that every string that went into the logger should be parsed and should be assumed to have data other than what should be displayed. So the assumption that all of the data has formatted strings and that it's appropriate to use those formatted strings is part of the problem here. It is important also to recognize that the calls we were looking at are made regardless of the log level because it went through .log, and regardless of if you're using the formatted logging or how you're doing the log formatting. So this is not something that you could just get away with by using the printf kind of statements on the logger or by only logging through things other than error. I know Sophos, for example, gave an explanation and they said incorrectly that it's logger.error, but it's not logger.error, it's actually logger.log, which ultimately everything winds up calling through if it's logging, and that's even if you're doing the formatted strings or if you're doing something like info, debug, trace, they're all vulnerable. You can see this in action if you want to with the super vulnerable Java application. We are actually leaving that library such as it is, at least for now, so that people can play with it. Do be aware that it is purposefully left vulnerable in that regard. This is actually abnormal for us. Typically, if it's a library issue, we are going to patch it because, as we've mentioned before, attacking libraries isn't the most useful thing. Not if you're a software security engineer or a software developer, because a library is a more universal issue as compared to if the problem is in my own code. I can control problems in my own code. It's a little more difficult when it's something outside of my sphere of influence with regard to anything that I am sucking in from some third party, be it Java libraries, C# libraries, Ruby, Python, whatever, external, any of those third-party libraries, or the core libraries that come with the actual language itself, and that would be regardless of the language. So we don't typically go after those in our examples here because it doesn't teach you, but this was one that there's a lot of confusion and a ton of misinformation on. An absolute positively massive amount of misinformation. Our recommendation is to always be mindful if you see a $sign and a curly bracket. So and that's encoded or otherwise. That's something that you see across Apache's products. So for struts and for things like Log4j, this is actually the most common attack string.
If you haven't already, please like, subscribe. It's very appreciated, much appreciated. And if you guys definitely want to hear different things or have new topics you want us to discuss, please add them down in the comment section. You can email us. You can badger DaRon. I mean, you can do whatever you want. Badger me all day. You can spam his email with content that you want. Don't really spam his email, but you can definitely let him know or let us know some of the things you want us to discuss. And even if you want to be on the podcast in the future, we're looking to get maybe some people on to discuss some things or things they like. We had a few people reach out to us, so maybe we'll do that in the future. But anything you want us to talk about, please put it down in the comment section. Other than that, thank you guys for your time. I'm Roniel.
I'm DaRon.
And see you on the next podcast.
Have fun.